Hey everyone, welcome back. In this video, we're diving deep into Express.js sessions, from basic setup to production-ready security. By the end of this tutorial, you will understand how to configure sessions properly, essential security practices like httpOnly and sameSite cookies, building authentication flows, the biggest pitfall of default session storage, and also critical security methods like destroy and regenerate. No more guesswork, you will know exactly how to implement secure sessions in your Express applications. Let's jump right in. As usual, I've prepared the basic Express setup so we don't waste any time. If I visit the session endpoint, you'll see a simple HTML template that I'll be populating with session information. Now go back to the code base, stop the server, clear the terminal and install Express session npm I express session. After installation, the next step is to import it to the project. Import session from Express session, and after this we're gonna initialize using app.use. So we tell Express to start managing sessions for every incoming request. So app.use session and open a curly brace. And here I'm gonna show you all the options you can set for your Express sessions. Let's start with secret, which is the most important option from a security perspective. Secret is used to sign the session, ensuring it can be tampered with. For the secret, you want something that's really hard to guess. A common practice is to generate a long random hex string, which you can easily do using Node.js built-in crypto library. Using this command that I'm gonna share with you in the video description, you can generate a long hex string, which is perfect for session secret. Obviously, I don't have to tell you, but the best option for storing this long string is to create a new environment variable. So copy, go to the env and session underscore secret equals this long string, and in the session object I'm gonna add it to the secret option process.env session secret. And don't forget to add import.env/config to the index.js to make every environment variable working. In development, you can also add a fallback secret, which can be used if for some reason the environment variable is not set, but in production you really want to avoid that. Never rely on a fallback secret, only use a strong secret from your environment. For the sake of this tutorial, let's add a fallback secret, which can be used like or, and just write something here like secret. So this is the fallback secret. I'm just gonna delete it. Next, we have the name option, which defines the name of the session cookie in the browser. By default, Express uses connect.sid for naming. While this works fine in development, for production I strongly recommend changing it. A custom name looks more professional and it doesn't immediately signal to potential attackers that you're using Express.js. So this simple change adds a small but valuable layer of obscurity to your application. So for this tutorial, I'll stick with app session underscore session. This is clear, professional, and gets the job done. Then we have the cookie object, which controls how the browser stores and sends the session cookie. This cookie doesn't store the full session data, it just stores the session ID, which acts like a key to the real data on the server. The cookie object has several important options for security and behavior. So cookie, open a curly brace for cookie options and start with maxAge. maxAge defines how long the session cookie should live in the user's browser. It really depends on your use case. For sensitive apps like banking, you want much shorter sessions, maybe a few minutes. For a blog or a dashboard, longer sessions are fine. I'm gonna do a 1-day session, so 24 hours are multiplied by 60 minutes, multiplied by 60 seconds, multiplied by 1000 milliseconds, because maxAge expects milliseconds. This will give you 1 full day. Next, httpOnly. This is a crucial security setting. When enabled, it makes the cookie inaccessible to JavaScript. This helps protect against cross-site scripting attacks, because even if malicious script runs on your page, it can steal the session cookie directly. So set it to true in development and in production as well. Then we have secure. Secure ensures that the cookie is only sent over HTTPS connections. You should always enable this in production to prevent any attackers hiding on your network from reading the cookie. Since you typically don't use HTTPS in development, the best practice is to conditionally enable this based on your environment. So I go to .env and under port I create a new node/env variable which I will set to development. And I go back and process.env .node_env equals production. So this means if the environment variable set to production, secure will be true, but in development it will be false, so we can develop easily our application. And finally, let's talk about sameSite. sameSite setting is really powerful. It can protect your app from cross-site request forgery attacks by controlling when cookies are sent on cross-site requests. Now, what are cross-site requests? A cross-site request happens anytime a request to your website comes from a different website. So this is incredibly common. It can be perfectly harmless, like a user clicking a link to your site from a Google search result, a Facebook post, or even an email. Or it could be malicious, like a hidden form on a fake website that's trying to make a request to your change password or delete account endpoint, hoping that the user is already logged in and has an active session. Now, if you want to learn more about this topic, I will link 2 videos regarding this, cross-site request forgery and cross-site scripting as well. As you can see, there are 3 options to choose from: lax, none, and strict. None means that the session cookie is always sent, no matter where the request comes from. Strict means that the cookie is only sent if the user is already on your website. Lax is kind of the balance between the two, because it allows the cookie to be sent during navigation, like clicking a link from another website, but blocks the background requests, like form submissions. For most applications, lax gives you the best balance of security and user experience. Users can click through from Google or email without losing their session, but you are still protected against most common CSRF attacks. so I go with Lex as well. Okay, we are done with the basic session setup. Now let's check the browser how this looks. In the session endpoint, I'm gonna make some changes. In the p tag here, I'm gonna display the session ID separately. So json.stringify request.session, and you can do here session.id or just session ID. I'm gonna go with session.id, and here at the pre tag I'm gonna stringify the whole session object along with the session ID. So json.stringify, open a curly, id equals request.session.id and request.session, and also add a null and to display it more beautiful, not just a straight line. Okay, let's start the server. npm run dev. Let's check the browser. Here you can see the session ID displayed separately. Here you can see the whole session object displayed with the ID and also the cookie, and also you can see every option we set in the backend index.js for the cookie appear here as well. One thing we didn't talk about is the path, which is set to / the root. This means that the session cookie will be sent on every route and path of our website. If we set it to something like /admin, the cookie would only be sent when accessing routes under /admin, but for most apps, / is what you want, so the session works across your entire application. Now you might be wondering if you can actually see the cookie in the browser, and of course you can. So just go right click, inspect. In the DevTools tab, just go to application, and under the storage, here is the cookies tab. Choose localhost 3000. Now initially you won't see the cookie appear here because this is our initial load. So during initial load, the server tells the browser that here is a cookie, a session cookie, save it for future requests. So when you actually refresh the page, which is technically a new request made to the server, the browser remembers, oh, I previously got a cookie from this site, here it is, check it out. So if I go to refresh it now, you can see the cookie actually appearing. You can see the app_session name we set previously, and you also see the value, which is the session ID. So you can see here it starts with p_n_age_i, and here you go p_n_age_i, and you can also see some more information like expiry date, and httpOnly is checked in, sameSite option is set to Lex. So you can see all these options, all these cookie options appearing here as well. Now that our session is working, I need to point out something important about this setup. By default, Express Session uses in-memory storage. This means that all session data, like user logins, preferences, cart items, is stored directly on the server's RAM. So nothing is saved in a database or a file system. This is completely fine for development or testing, but it has some critical limitations when it comes to production. Let me show you why. As you can see, I've added a login form to our application and also a protected route called dashboard. Now let's check the code. I've created a simple users array that will act as our temporary database for this demo. Here, the login form will make a post request to the /login endpoint and send the email and password data along. If I scroll down to the login endpoint, you can see a basic authentication flow happening here, which will check if the user exists and validates the credentials. If there isn't any user, we will get a response invalid credentials. But if there is a user, we'll populate the request session.user object with the user's email and then redirect the user to the session endpoint and see what's changed. And here, the dashboard endpoint, we first check if there is a user linked to the session object or not. If not, we redirect the user to the /session endpoint. But if there is a user, so there is a valid logged in user, we display this HTML template with the short welcome text and the user's email address. Let's go back to the browser and see all this in action. So here, ban at express.com, 1, 2, 3, 4, 5, hit the login, and you can see our session object is populated with this user object and the email is added to this object as well. If I try to reach the dashboard endpoint, it's a success, and you can see the welcome text with our email address displayed here. Let's go back to the session info. Now, if you remember, I told you that Express Session by default uses in-memory storage. That means it stores the session data on the server, in the server's RAM, which is not a persistent storage like a database. So if anything happens to the server, it crashes, you need to restart it or something, all the session data, all this information that's stored in the in-memory storage will be gone. So let me show you how this works in real action. So let's go back to the code base and change something in our code, like delete this break, and the server restarted. So if I go back to the browser and refresh it, you can see our user's object is gone, a new session ID is generated, so we are back where we started. Now that I showed you the limitations of Express Sessions in-memory storage, there are two more critical security methods in Express Session that I want to show you. First one is destroy and the second one is regenerate. As you can see, I've added a logout button to our HTML template that I'm gonna use to demonstrate the destroy session. Now let's go back to the code and I'm gonna show you what I was cooking. Right after the dashboard endpoint, I created two logout endpoints, one demonstrating the bad way and one the correct way. Let's check the bad way first. If the user hits the logout endpoint, the request.session.user object becomes null, and then the user will be redirected to the /session endpoint. Now the issue with this approach is that the session cookie along with the session ID is still alive and valid on the server, so this will leave your users open to serious vulnerabilities. Let me show you how this works in the browser. If I go back and open up inspect just to show you how the cookie behaves real time. So go to application, localhost 3000. So I'm gonna log in. 1, 2, 3, 4, 5. Here you can see our cookie is set. So the session ID is YPY. In the cookie object you can see YPY app session. So if I scroll down and log out, you can see our user object is set to null, but the session ID didn't change. So it's YPY, here YPY, so it's the same. So the session is still valid on the server. So the issue with this is that an attacker that stole the cookie or the session ID could potentially reassign the session data and make valid requests, the user's name, and you're also maintaining so-called zombie sessions. It wastes our server's resource, and you give your users a false sense of security, thinking they properly logged out and their data and their app is secured, but not. So let's go back to the code and I'm gonna show you the proper way of logging out. I'm gonna comment out the bad way and let's activate the good way. So here, when the user hits the logout endpoint, I'm gonna call a destroy method on the request.session, which will destroy the session on the server, so the session becomes invalidated. And we are also gonna clear the cookie app_session and then redirect the user to the /session endpoint. Let's check how this works in the browser. I'm gonna open up inspect again, application, cookies, and here you can see the session ID, which is E13, starts with E13, E13. So I log in. 4, 5, login. As you can see, the user object is populated. The session ID is E13. So if I go and log out, you can see our user object is completely gone. And we also have a new session ID, starts with M6. So the cookie has been cleared as well. So this method deletes the session data from the server and makes the session ID invalid forever. And then in the callback function, we clear the cookie from the browser as well. So this ensures that the session is dead on both sides. Okay, I think the destroy method should be clear in your heads now. Let's jump to the regenerate method. This one is just as important but serves a different security purpose. While destroy is for complete logout, regenerate is for when you need to keep your user logged in, but want to invalidate their current session for security reasons. The most common use case for session regeneration is after sensitive actions like password changes, email address verification, login, and if any suspicious activity is detected. Let's go back to the code and I'm gonna show you how this works. I'm gonna scroll up to the login endpoint. Here you can see the authentication flow stayed the same as before, but after authenticating the user, I'm gonna call the regenerate method on our session object, and this will create a completely new session. And then, as before, we're gonna populate the user with the user data and then redirect the user to the /session endpoint. Now let's go back to the browser and see how this works. I'm gonna open inspect again, application, cookies, and here is the session ID. It starts with 9SH, and if I log in, you can see the session ID is completely new. Starts with NRC. The user is populated as before with the email, and I can go to the dashboard. I can see the email appearing here as well, back to the session info. So everything works perfectly fine. So why is it important to regenerate the session after logging in? By doing this, you can prevent an attack called session fixation. Session fixation is when an attacker obtains your session ID, the user's session ID somehow, and then when the user logs in, so validates the session, the attacker, knowing the session ID, can make requests to protected endpoints. But by regenerating the session, you can make the attacker's known session ID completely useless the moment you log in and authenticate. And that wraps up our deep dive into Express.js sessions. In the next video, we'll solve this memory session problem by implementing Redis database for persistent, scalable session storage that survives server restarts and even crashes. All the code from this tutorial is available in the GitHub repo link below. If you found this helpful, please like the video and subscribe for more in-depth Node.js content. Thanks for watching, and I will see you in the next one.